So far we got two alternative implementations for the stack ADT. We got a single stack interface on the top, and we got two implementing classes. One is array class, array stack, and the other one is the link stack. Both of them implement the same stack interface. Given such a nice architecture, we really want to see exactly how polymorphism and dynamic binding will actually work in this kind of architecture. So both concepts about polymorphism and dynamic binding are something you learned from the earlier advanced OOP course. I'm not going to teach you from scratch about these two ideas, but you can definitely go back to my EECS2011 lecture site. That's where I suggested a background study. You may just want to go over them if you want to, right? So that's something I assume you actually feel comfortable. Or you can just reach out to me. I can actually go over some basic steps or concept together with you. That's fine too. Right, let's now talk about specifically for our stack interface example, right? Let me just show you the logic for the code very quickly, and then I'm going to trace the code slightly, right? I'm not really in complete details. We don't need to know the complete detail. You can actually fill the gaps yourself. Right, so we have a unit test over here, test polymorphic stacks. So where can you find the source code for this? Again, you can simply go to the source code I made available to you, and go to the test stacks class over here. And then you will see we got test polymorphic stacks over here. So that's the one we are looking at, right? There might be something I can actually use the breakpoint and debugger to show to you at the end, right? Let me do the paper tracing first. Okay, let's now go over the code very quickly. So we declare a stack, right? Notice that we got a type on the left hand side over here. We got a different type on the right hand side over here. Now here's a question for you. Can we say array stack over here and we say stack over here? Or can we say array stack over here, but we say link stack over here? So that's some pop quizzes for you, just to check your basic knowledge about polymorphism and dynamic binding. If you have any doubts about how to answer my two earlier questions, that means you really got some shaky foundation for polymorphism and dynamic binding. In that case, you are really advised to really go over the basics for those two concepts in the 2030, right? Right, let's say we do such declaration, and then we're gonna push three elements in this order: Alan, followed by Mark, followed by Tom, right? So here I said they should really demonstrate dynamic binding. So we'll see exactly, okay? And then we're gonna assert that after three pushes, the size should really become 3, and then stack is not empty. Very easy, right? And also we can make sure Tom is the top, right? Last in, first out. This was the last one that's pushed. Of course, that should be the top. And we are going to use the same variable s over here, and we're going to say it's going to be it's going to store the address of a new stack object. But in this case, you can see it's a link stack as opposed to array stack. So what does it really mean, right? And we got another 3 pushes the same. So now the question is, here we got exactly identical 3 lines of code as like this, these 3 over here. However, are we calling the same version of the push method in the array stack or in the link stack, or we're calling different versions? So that's a question to really make sure you understand dynamic binding, okay? And also we make sure again the size, and also it's not empty, and we can also make sure Tom should be the top still, right? Because we're following the same order, right? So that's about the code I want to go over with you. Let's now do some annotation quickly, right? And also I want to trace just for the array part. For the linked list part, we did lots of tracing about how to add first or add last. You can actually do the tracing yourself. But I'll mention something just for give you some guidance about the exercises. So this is where we declare the stack variable s over here, right? You can think about this one here is what we learned from 2030. This is called a static type. And on the right hand side, we can assign the new objects over here. So this part over here can be any class that's actually the descendant class of the static type over here, right? So according to the architecture we have, if the stack was declared as a static type, what are the possible dynamic types we can have for stack? In this hierarchy over here, it can be either array stack or link stack. And by the way, you simply just cannot say new stack, right? So let me just mention that. If you try to say, for example, stack, and let's say stack of string, s is simply new, and then you also say stack over here. This will be disallowed. by Java, right? So this is not allowed because the interface type cannot be a dynamic type. Interface cannot be a dynamic type because you simply don't have any method implementation. You only the interface type only contains the method headers without any implementation. Right? That's also the basic knowledge I assume you know, but I just want to remind you, right? If you got any trouble understanding it, you may want to do some background study about interfaces. Let me move on. So we call that the array stack over here is really so-called the dynamic type. And similarly, you can see in this particular line over here, we are also trying to reassign the variable s to really store the address of another object over here, right? So for that one there, it's really reassigned to some link stack. You can see now after this line over here, dynamic type changes. So what's really the best way for you to verify the dynamic type? You can definitely do the breakpoint and debugger to check it. I'll show to you, but the way to read what you learned from the earlier course is you can use the instance of operator. So let's say we want to insert a line over here right after the reassignment, right? Insert a line in the post states basically for this object creation. And also we want to insert another line over here, let's say, right after we do the reassignment. Let's say we got star over here and also we got star star, right? So star is the timing after we have done this particular assignments, initialization. And star star is really the timing after we have done this reassignment, right? So let's say we talk about, in the case of star, if you try s instance of the interface type, and also you try s instance of, actually, it should be a single word. Instance of, let's say, array stack. And also we got s instance of, also link stack over here. Okay, let me try to save some space. Let me just draw, make some better comparison over here. Let me just make them a little bit smaller over here. Okay, so we talk about two different timings over here, right? Either star or star star. Okay, so instance of is actually a Boolean operator. So we talk about two different timings, either star or star star over here, right? Well, in the case of s instance of, let's say in the timing of star over here, what should be s instance of stack? Well, that should be true, right? Instance of array stack, that's the dynamic type, that's also true. What about instance of link stack? In that case, it should be false, right? Basically, you want to recall when you try to say s instance of stack, you're basically checking whether or not the dynamic type of s is actually a subclass of this type over here. Well, that's also something you learned from the earlier course. So s over here, and when you try to say instance of, you're really checking to see is the dynamic type of s, the left-hand side variable, a descendant class. Descendant class of stack, right? That's something I assume you know. I'm just trying to help you recall very quickly. And in this case, is dynamic type for s at this point is actually array stack. Is array stack a descendant class of itself? Yes, so that's why it's true. Is array stack a descendant class of link stack? No, because they actually exist at the same level. So array stack is actually not a descendant class of link stack, so that's why it should be false. Right? Following the same logic, let's say now we are talking about after this reassignments, what's happening over here. So the dynamic type for s has now changed to link stack. So what's going to happen is we're going to get the dynamic type for s right now has now been changed to link stack. Is link stack a descending class of stack? Yes, right? Link stack is a descending class of stack, so that's why it will be true. Is link stack a descending class of array stack? No, it's not. Right? You can see link stack, the dynamic type, is not a descending class of array stack, so it's false. And is link stack a descending class of itself? By definition, it is. So that should be true. Right? It's actually quite important for you to see how to really use your prior knowledge about OOP and apply it over here. Right? Right? And the final thing I would like to trace very quickly with you is about visualizing exactly what's happening over here when we do the reassignments, and also what's going to happen when you actually try to call the push over here. Right? Let's now try to do that quickly. Okay? So I got very limited space left, but I think it's doable. Let's talk about S over here. After this line, after this assignments, what's going to happen is we say S is actually pointing to an array stack objects. Okay, so array stack. I'm just going to say AS for array stack. And remember, one of the attributes is actually the data array. So that'll be the data array. And the data array is actually pointing to, if you recall, the maximum capacity is actually 1000, right? So we actually got 0, 1, 2, all the way to 999. 0, 1, and 2, right? So far so good. And you can see at the moment, because S is actually pointing to some objects of type array stack. So that's why the dynamic type is actually array stack, right? That's another way to visualize it. And when we actually say S.push, because the context object S right now actually got the dynamic type array stack. So we are going to call the push that should actually define in the array stack version of the array stack class over here, right? That's dynamic binding. So over here you can think about this part over here, the context object over here. For all these, the dynamic type is simply array stack. I'll say AS, right? And so that means we're going to call the push over here, right? And remember, the top index initially is actually -1. You can think about conceptually the top index is really initially just pointing to -1 conceptually, right? It's not pointing to any valid index. And let's just do two pushes just to see. When I say push ln, right, it's actually not exceeding the maximum capacity, so we don't really need to worry about it. So what we'll do is we're going to increment the t by 1, right? So t is now going to be incremented to 0. So it's basically conceptually pointing to here, index 0. And then data at index 0 is going to be assigned to e, which will be ln. So that means at index 0 is actually going to point to ln. So this will be the top of the stack at the moment. Let's do one more push, and then you'll see how things work. What about a second push for mark? In that case, we're going to execute this method again. So I'm going to say t++. So that means t, rather than conceptually pointing to index 0, is now going to point to index 1 over here. And then we're also going to execute this line over here. Data at index 1 is going to be mark over here. So that means at index 1, we're actually going to point to mark, right? And etc. You can see here, dynamic binding makes sure we call the corresponding version of the method that's defined in the dynamic type for the context objects. In this case, it will be the array stack versions of push, right? And let's now talk about what's going to happen if we try to do this reassignments. For this reassignments, what's going to happen is we're going to, this part over here, we're actually going to say S, rather than pointing to over here, is actually going to point to another brand new object over here. So that will be the link stack. So link stack over here, LS for short. And that one there actually got, if you, let me show you the definition, right? I'm not including that in the iPad notes over here, but you can take a look. If you go to link stack, we actually got some private attribute over here, the data, but that one, the data is of type singly linked list, right? So this one here, also we got data, but that one there is initially just pointing to some singly linked list, right? Remember, a singly linked list is just another object, just another class. Singly linked list, and also we got size, we got header, and also we got tail. And for the detail of this tracing the singly linked list, I'm going to leave that to you as an exercise. But what I want to point out is, now if you look at the push over here, depending on whether you're using strategy number 1 or strategy number 2, you're going to invoke different methods in the singly linked list, right? So for strategy number 1, if that was adopted, for the push, it's going to invoke at first. In case strategy number 2 was invoked, in that case, we're going to invoke at last. But in the version of the source code I gave to you, let me just double check for you, it's actually strategy number 1, right? So just make sure you actually can see exactly how things go. I think I will actually use the debugger to show to you, just conclude this part. And let me see what else. I want to allocate just this part over here. You can see the context object over here is, right? So here, for this part over here, the dynamic type has been changed to, because of this reassignments, dynamic type will be linked stack over here, right? So that means the push over here, even though we're calling the push method, which was defined in the stack interface, but the actual implementation was actually defined in a different class. In this case, it will be the array stack. So, link stack. That's what I meant. So if you that means we're going to call this push version. So we got two versions of the pushes. Either this version over here for the link stack, or this version over here for the array stack over here. Right? That's something that might be the best to be demonstrated also by using a debugger. I'll show that in just one moment. Okay. Alrighty, so that's about what I want to do to trace the code. You should really you should really recall what you learned in the earlier course about polymorphism, because you can see S over here being declared as the interface type now can be assigned or reassigned to any descendant class type as the dynamic type, right? That's polymorphism. For dynamic binding, which version of the push method or any method that's being called depends on the dynamic type of the context objects, as we illustrated over here, right? Let me just do one more annotation, and then we'll switch to the debugger. So the push method over here is actually the version of the push method in array stack, and the push methods over here will be the version in another class corresponding to the dynamic type for the context objects in the link stack. All right, good. Let me now show you that the next slide is really the same example over here. So I'm not going to trouble you with that, but I would suggest you also go over this slide. It's like a simplified version of what I just illustrated on the iPad, right? So here, just about polymorphism. So polymorphism is really illustrated in line number 2 and 4, right? You can see line number 2 and line number 4. In line number 2 and line number 4, what kind of variable assignment will be valid? It depends on polymorphism. As long as the right-hand side dynamic type over here is actually a descendant class of the declared type of the variable, in that case, it will be valid assignment. So that's polymorphism. For dynamic binding, so whenever you're calling methods in line number 3 and line number 5, as I said here, the version of the push that's going to be invoked depends on the dynamic type for the context object at that point. In this case, my stack will be array stack. In this case, my stack, the dynamic type will be the link stack, right? Similar example. Let me show you finally, just to see how we can illustrate dynamic binding in Eclipse quickly. Right? Let me just close everything over here, and then we're going to go to test stacks over here. Right? Let me just maximize it. And I want to use the debugger to really go through this particular class, right? Let's now go to over here. Let's put a breakpoint right in the beginning. Okay, and then we're going to launch the debugger. I would suggest you do this exercise together with me, and also make sure you can reproduce it yourself. And let's switch to the debug perspective. And now we're pausing over here right before we try to do this initialization. Okay, let's now do it. If I say step over, so after executing line number 43, so I want to show you first of all the dynamic type over here. You can see S over here is really pointing to some array stack object. So this part here is the dynamic type. Another way to verify it would be, let me just delete my expressions from before. So I can say remove all. Okay, so now I want to show to you the table I drew before. S instance of stack, and also S instance of array stack. Both are true. And also one more, S instance of linked stack. Oops, so I should really spell it properly. S, oh, sorry, caps on. Like that, right? So you can see this one is false. And now let's take a look at the dynamic binding. At the moment, the dynamic type for S is actually array stack. If I step into the push, which version of the push am I going to see? It should be the one that's defined in array stack, because link stack is not a dynamic type at the moment, it's false. If I say step into, you will see now I'm now in the context of array stack, and that's the version of the push I'm executing. Right? That's all I want to show to you. And of course, you can actually trace the code further, which I also did in the iPad. Let me say step return. So now I'm back to this line here. Let's now execute the push, execute it, and now I'm now in line number 50, right before I try to reassign the dynamic type. I want you to watch out for this table over here. Currently, it's true, true, false. As soon as I actually say step over, what's going to change? Well, so that means dynamic type is going to be link stack rather than array stack, but it will still be a descendant class of stack, so this will remain to be true. If I say step over, you can see that's the flip, right? You can see now it's still a stack, but dynamic type is now link stack instead. And which version of the push am I going to see? Well, if I step into, I'm going to see the version not from the array stack. I'm going to see the push version, the version of the push from the link stack. If I say step into, you can see this is the push that's really defined in the implementing class of link stack, right? So that's really important for you to see the polymorphism and dynamic binding, how they work. You shouldn't forget about the details that you learned from the earlier OOP course. Let me stop it and then go back to Java perspective. Okay. Right, so that's all I want to say about polymorphism and dynamic binding. So later on, for the other ADT that we're going to speak about this week, which is about the queue, I got similar slides over there and also illustration. I wouldn't repeat the illustration again, but you should really try to do that as an exercise for yourself.